Morning, welcome back. Today we are going to solve a transformer problem. The primary and the secondary windings of a 500 kV transformer have a resistance of 0.4 ohm and 0.001 ohm respectively. The primary and secondary voltages are 6600 volt and 400 volt respectively. Along with the given data is iron losses are given. So we need to calculate the efficiency on full load and the load power factor being 0.8 lagging. So the given data are the capacity of the transformer, the given data which is nothing but output power, and the primary winding resistance R1 0.4, R2 is 0.001 ohm. This only given, and from the data the primary voltage is 6600 volt and secondary is 400 volt. So from this we can calculate the value of K. As we know, K is equal to V2 by V1. That is going to be K value. So along with first to find full load efficiency, we need to find out the full load parameter of full load current. So full load current, we can calculate the given output power by the voltage. That's nothing but VA by V1. As we know, the power is equal to kVA, where P is equal to V into I. From that, if you want to calculate I, that's nothing but VA by V will give the I value as a 75.75 ampere. Already we have calculated the K value. So as we know, the R2 dash, which is the secondary winding resistance referred to the primary, as like this. This comes like this. So from secondary winding resistance R2 comes here as R2 dash. So that's nothing but 0.2725 ohm. Now, anyhow, we are having a resistance value R1 and the winding transferred secondary to primary, that is R2 dash. The total resistance, which is nothing but R1 plus R2 dash. So that is nothing but this term. So by the way, we are calculating the R1E, total resistance for the integrators. So now we can calculate the full load copper loss, that is nothing but full load current square into total resistance, I square R. So from this full load current, which is 75.75 square, and our total resistance will be 0.6725 as we calculated. Finally, we are getting that copper loss will be 3858.1764 watts. So simply we can calculate the percentage of full load. Percentage of full load efficiency is output power by input power actually, but input power which is nothing but output power plus losses. So that VA cos phi, which is the output power, VA cos phi plus copper loss PQ and PI iron loss. So that as we know, VA cos pi, VA which is nothing but 500 kVA into 10^3, cos pi which is 0.8, here also same term, and then our copper loss will be 3858 and the core loss or iron loss which is given as a 3 kilowatts here. So by the way, we are calculating that full load efficiency as 98.31%. Thank you.